Okay, good morning students. As you know, my name is Subodh Pandey and you are floating with me in the world of physics. We are going through a chapter and the chapter name is surface tension. And in that chapter, we have completed your viscosity, and after that we have completed your topic, that is your Stokes law, and after that finally we came to a topic. The topic is terminal velocity, as you can see on your screen. Okay, so what basic sense of the terminal velocity, what did it mean, what is its use, and why we discuss about the terminal velocities. So these questions are in our mind, so one by one we will discuss each and everything for you. So let's get started. Firstly, we will see that when the term terminal velocity comes. So for that you have to aware that if let's suppose this is your container like this way, okay, and we have some fluid in it, let be like this way, okay, this is your fluid, let be, okay, and in that fluid you drop a solid object, solid body like this way. You have just dropped, okay, so that solid body is dropped. Now as you can see that when you will drop it, then what will happen? Then you can simply say that due to its own weight, it suddenly tries to move inwards, or we can say deeper side in the fluid. Okay, so basic sense of the terminal velocity means you can easily understand. Terminal means last, okay, and velocity you know very well. Okay, so we conclude that if any spherical body, solid body is dropped in the fluid, then at last it has a constant velocity, and that velocity is termed as terminal velocity. Now why it goes down? The reason is obvious, due to its weight. Okay, so now we are in need of that how many forces are participating in this phenomena. So as you visualize that first force, that is force of gravity, or we can say that it is a weight of the body, and due to the weight of the body, solid body tries to move inward or deeper inside the fluid. So this is your one thing. Now as we know that when any body is in fluid, then it tries to float, and the fluid applies a force that is in upward direction, and that is termed as your buoyant force. So due to the buoyant force, a body can float on the fluid. So up to here we have two forces. First one is your weight, second is your buoyant force. But one more thing is there. As Stokes told us that when any solid object, when any solid body passes through any fluid, then a viscous force, a dragging force which opposes the motion of the body also acts, and the reason is viscosity of that particular fluid. So it means we can simply say that because the direction of the motion of the body is downward, so this is the direction of motion. So for opposing the motion of the body, there must be a viscous force. Okay, F be the viscous force. So overall, if we talk about that at some instant, let be the this is the final position of the object. Okay, it is dropped from position A, and the final position, let be, it is B. Okay, so we can simply say that at point B, because it is termed as the final position, so at that position, what is the velocity? It means at that time the body must be in equilibrium, and if the body is in equilibrium at that position, at that condition, so we can easily say that all the forces at that time will be in equilibrium. Okay, so in equilibrium condition, in equilibrium condition, and the body is equilibrium at position B. Okay, so in equilibrium condition, or we can say that at position B, we have two forces. First is your viscous force, second one is your buoyant force, and both forces are acting in upward direction. Okay, so these are the upwards forces, whereas the weight, that is in downward direction, downward. And according to as I have explained to you, as I have told you, that when any object is in equilibrium, so the forces must be balanced and equal. It means whatever the forces are in upward direction, that must be balanced by the forces in downward direction. So we have a final result, and the result is F plus FB, and that must be equal to capital W in the equilibrium condition. And when it is in equilibrium condition, then we can assume that the velocity will be terminal velocity or the final velocity. Okay, so what we have learned before it, we have learned, let be this is equation 1 or equation A. Okay, so we have learned that the viscous force is given by a formula, that is 6 pi eta RV, and that is your Stokes law. I hope that you know it very well. Okay, I also told you that the buoyant force FB, and that must be equal to the weight of the fluid, displaced by the solid body, okay, solid body. So weight is nothing but that will be mg, and if we consider that the fluid has density, if fluid density, so fluid density is considered as rho. If the fluid density is rho, so we have density equal mass upon volume. So in place of mass, we can write density into volume into G. So I hope that up to here each and everything is clear. Now what is the formula for volume? Because as you can see here that I have considered that the shape of that body is spherical. So we can simply write that the volume of a sphere, that will be 4 by 3 pi r cube. That is the volume, and into G, and that will be FB. Now one question is obvious, there is a confusion among the students that we are talking about the weight of the fluid displaced, but we take the volume of the body. And why? So you can easily see in this diagram that whatever the volume of the solid body, the same volume must be displaced by that body. It means the volume of the solid body must be balanced by the volume of the fluids. Okay, so that's why in place of volume of fluid we take the volume of the solid body, because in terms of volume both are equal. Okay, so this one is I hope that it is clear. So it is your buoyant force, so Fb. Now we will come to the next force, because we have three forces are there. This is your F, viscous force by Stokes law. So this is by Stokes law. Fb, that is your buoyant force. So this is your buoyant force Fb. And now this is third force, or force of gravity, or weight, you can simply say that. So weight is nothing but it is also equal to mg. Now again I have told you that mass can be written as density into volume. So if body density, it means the solid material which is used to form the body, so body density we can simply say that. Okay, so if the body density is sigma, so we can write sigma equal mass upon volume, and that will be quite similar to sigma times and volume into g. Now volume must be equal, as I have already told you. So in place of capital W we can write sigma into 4 by 3 and pi r cube times g. Now what? We have the value of Fb here. Okay, we have the value of Fb. This one is the value of Fb, buoyant force. This is the value of capital W, and we have the value of capital F, or the viscous force. So all these three values we can put in equation number A. Okay, so let's get started. We will put the value and see what we get the answer. So we have the final result, that is your F plus Fb, and that is equal capital W. And what is F? So F is your 6 pi eta Rv. So we can write 6 pi eta Rv plus Fb. So what is the value of Fb? Fb is rho times 4 by 3 pi r cube into g. Okay, so it will be rho times 4 by 3 pi r cube g, and capital W. So W is your sigma times 4 by 3 pi r cube into g. So we will put sigma times 4 by 3 pi r cube into g. Okay, so we can write that it will be 6 pi eta Rv, and that must be equal to, if we take common 4 by 3 pi r cube g, then it will be rho minus sigma, sigma minus rho. Okay, so we will correct it and write like this way. So it will be sigma minus rho, okay, times 4 by 3 pi r cube into g. So I hope and I believe that up to here each and everything is clear to all of you. Okay, now we will cancel out what we can cancel. So here you can see that pi and pi cancel out, first thing. Second, 2 3 are 6 and 2 2 are 4, we can cancel out, and r can be also cancelled out. So it will be r, and here power remains 2 only. So finally we get here 3 times eta times v. Okay, and here we get sigma minus rho times 2 by 3 r square g. Okay, now what we have to calculate? We have to calculate the value of terminal velocity. So v is the terminal velocity. So what will be the final answer? That will be v equal, we can write 2/9 times sigma minus rho r square over eta into g. So this is your final expression for the terminal velocity. So I hope that this derivation is quite easy for you to understand. Now, as I have so many times told you that what you have to do, you have to try to solve this derivation by yourself. Firstly, remember what things I have explained to you, what are the basic concept behind this derivation, and when we know every concept, what is the condition of equilibrium, what is the sense of the terminal velocity. Terminal means last velocity. It means at that time we consider that the body must be in equilibrium, so all the forces must be equal. So the question is what are the forces are there, how many forces are there, what are the nature of the forces are there, okay, what are the direction of the each and particular forces, and after that we will balance and we get the final result as v equal to by 9 sigma minus rho r square over eta times g. So I hope and I believe that this topic is clear now. Now we will discuss a numerical for you, and as you can see here, this is the question. Question is that you have to find the terminal velocity of raindrop. Okay, so here raindrop is also considered as the spherical shape. So the radius is given to you. So let be that r is given, that is 0.01, and that is in millimeter. So you have to convert it in meter. So 0.01 into 10 to the power minus 3 meter. So this is the radius of the raindrop. Now coefficient of viscosity of air is also given to you. So eta that will be 1.8 into 10 to the power minus 5 Newton second meter inverse 2. Okay, density is also given. So density and density, here you can see that this density is density of air. Okay, so air is basically the medium or the fluid, and the raindrop is basically the spherical body. So because we have considered here, as you can see that I have written that if the fluid density is rho, the fluid density is rho, so we take the same rho, and that is the fluid density, and here fluid is air, so rho will be 1.2 kg meter inverse cube. Okay, density of water means raindrop is basically body, so it will be sigma, and sigma that will be 1000 kg meter inverse cube. Okay, and it is given that you have to take small g, and the value must be taken as 10 meter second minus 2. And what we have to calculate? We have to calculate the terminal velocity, and the terminal velocity, the symbol we have taken here v. So what we have to do now? We have to apply the formula for the terminal velocity. So the formula for terminal velocity, as you can see that v equal 2 by 9 sigma minus rho times r square upon eta into g. So this is the formula what we have derived. So by using the same formula, and that is v equal 2 over 9 sigma minus rho times r square over eta into g. So this one, sigma minus rho times r square upon eta into g. So the same formula we are going to use here, and we will put the value. So 2 by 9 times, now sigma minus rho. So you can see that sigma is your 1000, rho is 1.2. So 1000 is quite greater with compared to 1.2. Okay, so we can directly write that it will be 1000 minus 1.2. Okay, and bracket close. Let this bracket be small because the length of the bracket is 2. Okay, now divided by divided by eta. So eta is your 1.8 10 power minus 5. So it will be 1.8 into 10 to power minus 5. This is eta into r square. So r is your 0.01 10 to power minus 3. So 0.01 into 10 to power minus 3 and the square of it, because here there is written r square into g. So value of g is your 10. It is given in the question. So it can be written as 2 over 9 into, now if we divide 1000 minus 1.2, then what will we get? So few of you are unable to subtract, as I have already found that few of you have some problems. So when we have to subtract in numbers with the decimal numbers, then the pattern is like this way. So if 1 carried, so it will be becomes 10 minus 2, so it will be 8 point, this will be nothing but 9 and 9. So 999.8, that will be your answer of the subtraction here only. Okay, so we will rough it and we get the result as 999.8. So we will write that it is 999.8 and divided by 1.8 into 10 to power minus 5 into, and now look here, when we remove this decimal, then 100 will becomes in divide or denominator. Okay, and the 100 will move in numerator, then power will become minus 2, so it will be minus 5. So it can be directly written as 10 to power minus 5 square, so minus 10. Okay, into 10. I hope that this step is clear to all of you. Now it can be rewritten as 2 by 9 times 999.8 divided by 1.8 into, that is 10 to power minus 10, so it will 10 power minus 5 will go up, then it will be 10 power plus 5, so remains minus 5, and here plus 1, so remains minus 4, so it will be 10 power minus 4. So I hope that it is clear. Now one decimal to one decimal cancelled out. Now what you can write? You can write that, firstly we will copy here, take a new slide and the copy the same, v equal 2 by 9. So here v equal 2 by 9 times 9998 divide by 18. Okay, so divide by 18 into 10 power minus 4, so 10 to power minus 4. So this is the result. Up to here we have solved it. Now what we have to do, we have to multiply and divide whatever is possible here. So as you can see that 2 1 ja 2 and 2 9 ja 18. Okay, and you can easily see that it can be written as 998 over 81 into 10 to power minus 4, that will be v. So after that you can easily divide it this thing and you will get your final answer, and the final answer what we get, that will be meter in second inverse. So I hope and I believe that the numericals based on the terminal velocity as well as the derivation of the terminal velocity, what is the sense of the terminal velocity, each and everything is clear to all of you. So if you have any doubt, then you can ask me, you can comment me, I will try to solve each and every doubt to all of you. Okay. And one more thing, what I have discussed, what I have told, what I want from all of you, that before proceeding to any concept, just listen the initial paragraph what I have dictated to you, because that paragraph what I have dictated to you in the initial of any lecture, that is very most important, because that is the logic, that is the concept. And when you are able to understand the concept behind any particular phenomena, then I hope and I believe that it is quite easy to understand the complete derivation, the numerical based on that one. Okay, so thanks for watching me, thanks for listening me, and best of luck to all of you.